In today's programme, we'll be blasting in a quarry, unpacking some ice sculptures. Matt will be working with penguins. We'll be taking a close look at a rainy day and getting tied up with balloons in Science Tube.
We are surrounded by materials. Rock is a raw material of the Earth. This rock is granite, which is extremely hard and strong, and so very suitable for all types of building work. We're at a quarry, where we'll find out how you can get from this to this. Taking the rock out of the ground is the first job. One way of doing this is to use a liquid explosive, putting it into deep holes. That's the custard-looking stuff. It's then all connected together. One press of the button well, that's certainly got the rock loosened up. Let's look at it again. It's going to be difficult going from large rocks to small chippings in a road. Lifting first. With just a little bit of extra smashing fun. That's a steel ball, a very strong material to break up the hard granite. The rocks roll down a chute and into a crusher next. There are two steel plates. One moves backwards and forwards against the other to crush the rocks. It's feeding time at the quarry. Sieving helps sort out the rock into different sizes. Once crushed and sieved, the rock's put in piles according to size. It's now called aggregate. This size of aggregate is just right for roads. But like this, it wouldn't stick. So it's mixed and heated with bitumen, a thick black gluey stuff. It's like a hot cake mix, and it's called asphalt. So a lorry full of hot sticky asphalt is on its way to a road. This road is being resurfaced. It's already had the old surface taken off. The lorry full of hot asphalt arrives and the road surfacing can begin. This machine spreads it evenly on the road. An extremely heavy roller flattens the asphalt. Those stones sure are strong not to crack under that weight. So next time you're on the road, just remember where it all started.
It's 3 o'clock in the morning, but all is not quiet in Norwich city centre. Some extremely heavy packages are being delivered from a refrigerated lorry. They're already well wrapped, but adding insulating material will stop the warm air getting to them. As they're placed around the city centre. All these packages started off as this. A large block of ice. Ice is frozen water. It's solid water. Here at an ice studio, the ice is going to be shaped and moulded into a sculpture. Different kinds of tools are used to cut and mould the ice. Look what's happening. So Duncan's going to have to work quickly. Ice is an extremely hard material. By placing this heated metal ruler onto the ice, Duncan's able to make marks because when ice is heated, it melts and changes to a liquid. The jigsaw is a good way of cutting curved shapes very accurately out of the solid ice. So, back in Norwich, let's see what the parcels contain. The bubble wrap and plastic help stop the ice from melting, returning to a liquid. Pouring water over the gaps between the sculpture pieces joins them together as the water freezes. All these ice sculptures have been made for the annual Norwich Ice Sculpture Trail, which is held before Christmas. So, you have to hurry to see it. It's already melting away. Leave it more than a day to see the sculptures, and they'll be liquid down the drain.
Here are some ice shapes made into penguins. When we heat them, they lose their shape. They've changed. Melted into a liquid, water. The liquid water is flowing. As the liquid gets hotter, it boils. The steam is a mixture of water droplets that you can see, and water vapour, a gas that you can't see. So, although water can be a solid, liquid, or a gas, it is still the same stuff, water.
A rainy day. We've all seen them. But have you ever stopped to think of where all the water comes from and how it got there in the first place? What if I told you that this water is the same water that's been on our planet for millions of years? It's all part of the water cycle. Let's zoom in closer than the eye can see. When the sun shines on the water's surface, it heats up and the water molecules get full of energy and move about. The more they heat up, the more they move about. They move about so much that they break free and rise up as water vapour, a gas. This process is called evaporation, and if you've ever watched a puddle dry out in the sun, then you've seen evaporation. So where does this water vapour go? Well, as it rises, the molecules cool and form into clumps, water droplets. This process is called condensation. If you've ever seen water form on the side of a cold drink, you've seen condensation in action. Water vapour in the air cools down quickly on the cold glass and forms water droplets. Clouds are made up of billions of droplets of water, all clumped together and weighing several tons. They become too heavy to be held in the air and fall back down to the earth as rain. Three-quarters of the Earth's rain falls over the oceans. The rest falls over the land and is absorbed by the soil. It slowly makes its way through the soil to rivers, which in turn flow back to the sea, and the whole process starts all over again. Water is constantly changing state, from a liquid to a gas to a liquid again. A reversible change that's been happening for millions of years. So next time you have a glass of water, just think you could be drinking the same water that the dinosaurs did.
This solid stuff is frozen carbon dioxide. Let's see what happens when Matt puts some inside a balloon. It's expanding. If Matt leaves the solid carbon dioxide at room temperature, it will warm up and change back to a gas. So the same amount of stuff takes up a lot more space as a gas than as a solid. Something in the air, nitrogen, is all around us, but we've made it so cold it's now a liquid. Matt's going to put this air-filled balloon into the liquid nitrogen. Let's see what happens. The air in the balloon contracts, then expands. When the air inside the balloon cools, it contracts. It takes up less space. When the air inside the balloon warms up, it expands. It fills the balloon again.